Hello children, now let us understand constrained motion. Sometimes while solving the equations of motion, the number of variables are one more than the number of equations available. In those cases, in all certainty, we are missing that one equation known as constraint relation. There are two methods to figure out constraint relation. First is considering segments of a string or strings, and the second is method of virtual work. We will understand both the methods with the help of this question. Two blocks of masses m1 and m2 are attached at two ends of an inextensible string which passes over an ideal pulley. If m1 is greater than m2, then find the acceleration of each block, the tension in the string. Two blocks m1 and m2 are attached to two ends of a string which is light and inextensible. Light means we don't have to consider its weight, and inextensible means its length is fixed. It doesn't change. This string is passing over an ideal pulley. Ideal pulley means it is massless and frictionless. We have to figure out acceleration of these blocks and tension in this string. It is given that m1 is greater than m2. So m1 will come down and m2 will go up. Consider their accelerations are a1 and a2 respectively. Tension in the string is T. This is a video of block M2. T is working upwards due to string. M2G is its weight. Since this block is moving up, so net force will be upwards, and that will be T minus M2G. So T minus M2G will be equal to M2A2. This is a video of block M1. T is working upwards due to string. M1G is its weight. Since this block is moving down, so net force will be downwards, and that is m1g minus t. So m1g minus t is equal to m1a1. Now there are three variables, a1, a2 and t, and we have got only two equations. So time to figure out that constraint relation, that is relation between a1 and a2. First method, considering segments of strings. Consider at t is equal to 0, length of this segment is x1 and length of this segment is x2, where these are the points where a string starts touching this pulley. As the time passes, this block moves down and this block moves up. So x1 increases and x2 decreases. We will consider increase as positive and decrease as negative. Amount of increase in x1 will be equal to amount of decrease in x2, as this is inextensible string whose length is fixed. So at any point of time, x1 plus x2 will be equal to constant. Differentiating both sides of this equation with respect to time, we get dx1 by dt plus dx2 by dt is equal to 0, where dx1 by dt is velocity of block m1 and dx2 by dt is velocity of block m2. We are considering increase as positive and decrease as negative. So dx1 by dt we will write plus v1 and dx2 by dt we will write minus v2. So v1 minus v2 is equal to 0 or v1 is equal to v2. Now differentiating this equation again with respect to time, we get d square x1 upon dt square plus d square x2 upon dt square is equal to 0. This is acceleration of block m1 and this is acceleration of block m2. Again, we will consider the same thing as increase of length as positive and decrease of length as negative. So we will write a1 as positive and a2 as negative. So putting these values in this equation, we get a1 minus a2 is equal to 0 or a1 is equal to a2. This is our constraint relation. Now we can solve equations 1, 2 and 6 to get a1 is equal to a2 is equal to m1 minus m2 upon m1 plus m2 times g, and t is equal to 2m1 m2 upon m1 plus m2 times g. Second method, method of virtual work. This method is based on the principle that summation of total work done by the system is equal to 0. Work done is equal to force into displacement in the direction of force. Consider this scenario again. This block is moving upwards. Tension is also applied upwards. That means applied force and its displacement both are in same direction. So work done will be positive and it will be equal to T into x2. In case of block M1, tension is applied upwards and block is moving downwards. That means applied force and its displacement are in opposite directions. So work done will be negative. It will be equal to T into minus x1. Take T common. So it will be T into x2 minus x1 is equal to 0. That means either T is equal to 0 or x2 minus x1 is equal to 0. T is not equal to 0, so x2 minus x1 is equal to 0. Now differentiate both sides of this equation with respect to time. We get dx2 by dt minus dx1 by dt is equal to 0. This is velocity of block M2 and this is velocity of block M1. So V2 minus V1 is equal to 0 or V2 is equal to V1. Now differentiate again this equation with respect to time. So we get d square x2 upon dt square minus d square x1 upon dt square is equal to 0. This is acceleration of block M2 and this is acceleration of block M1. And that is equal to A2 minus A1 is equal to 0 or A2 is equal to A1. So we have got constraint relation. Solving equations 1, 2 and 6, we get value of A1, A2 and T. This method is quicker than the previous method. So here onwards, we will apply this method to solve the equations of motion. To apply this method, we need to consider two variables. One, tension in the string, and second, displacement or velocity or acceleration of the connected object. And we need to take component of displacement or velocity or acceleration of connected object in the direction of tension of the string. Now let us see two questions based on string constraint. First question, find the acceleration of the blocks A and B in the given figure. Assume strings are light and pulley is ideal. This is the given figure. Block A is attached to this string and block B is attached to this string. These two pulleys are ideal. This pulley is fixed to the wall and this pulley is free to move up or down. Suppose tension in this string is T. It will be T everywhere. Suppose this block is moving upwards with acceleration A1. When this moves up, length of this segment will decrease and length of this segment will increase. As a result, this pulley will come down and attached block B will also come down. Suppose B moves downwards with acceleration A2. This is FBD of block A. Tension T works on it due to this string. M1G is its weight. Since this is moving upwards, so net force on it will be upwards and that will be T minus M1G. So we can write equation of motion as T minus M1G is equal to M1A1. M1 is given as 2 kg. So it will be T minus 2G is equal to 2A1. This is first equation. This is FBD of this pulley. Tension T is working on this string on both the sides. So tension on this string will be T plus T, that is 2T. This is a BD of block B. Tension 2T is working on it due to this string. M2G is its weight. Since this block is moving downwards, so net force on it will be downwards and that will be M2G minus 2T. So equation of motion will be M2G minus 2T is equal to M2A2. M2 is given as 1 kg. So G minus 2T is equal to A2. This is second equation. We have got three variables A1, A2 and T and only two equations. So we need to figure out that constraint relation, that is relation between A1 and A2. Focus on this block. This is connected to a string whose tension is T. This block is moving upwards. That means force and displacement both are in same directions. So work done will be positive. We can write T into A1. Focus on block B. This is connected to a string whose tension is 2T. This block is moving downwards. That means force and displacement are in opposite directions. So work done will be negative. We can write this as 2T into minus A2 is equal to 0. Take T common. So it will be T into A1 minus 2A2 is equal to 0. So either T is equal to 0 or A1 minus 2A2 is equal to 0. Since T is not equal to 0, so A1 minus 2A2 is equal to 0 or A1 is equal to 2A2. This is third equation. This is constraint relation. Now we can solve equations 1, 2 and 3 to get A1 and A2. A1 is equal to minus 2g by 3 and A2 is equal to minus g by 3. Negative sign suggests that the assumption that A is moving upwards and B is moving downwards is wrong. Actually, A is moving downwards and B is moving upwards. Second question, in the given figure, block M1 slides down a frictionless inclined plane. Find the accelerations of the blocks. Assume strings are light and pulleys are ideal. This is the given figure. Block M1 is connected to this string whose other end is fixed. Block M2 is connected to this string. These two pulleys are ideal. This pulley is fixed and this pulley is free to move in this direction. Suppose tension in this string is T. It will be T everywhere. Suppose block M1 comes down the plane with acceleration A1. When this moves downwards, this pulley will also move downwards. So length of this segment will increase or length of this segment will decrease. So block M2 will move upwards. Suppose block M2 moves upwards with acceleration A2. This is a BD of block M1. Its weight M1g works vertically downwards. Normal reaction by this plane works perpendicular to the plane. T is the tension that works on it due to this string. We will resolve its weight into two components, one along the plane, another perpendicular to the plane. Along the plane component will be M1g sine theta, where theta is angle of inclination of this plane. Perpendicular to the plane component will be M1g cos theta. Since this block is moving downwards, that means net force is working downwards, and that is M1g sine theta minus T. So we will form equation of motion as M1g sine theta minus T is equal to M1 A1. The other equation will be N is equal to M1g cos theta. This is a BD of pulley P. P is the tension force working on this string on both the sides. So tension force on this string will be T plus T, that is 2T. This is a BD of block M2. 2T is the tension force working on it due to this string. M2G is its weight. Since this block is moving upwards, so net force is upwards, and that is 2T minus M2G. So equation of motion will be 2T minus M2G is equal to M2A2. We have got three equations and we have got four variables, and the variables are A1, A2, T and N. We will apply method of virtual work done to figure out constraint relation. Focus on block M1. It is connected to a string whose tension is T. Block is moving downwards. That means force and displacement are in opposite directions. So work done will be negative. We will write T into minus A1. Now focus on this block M2. It is connected to a string whose tension is 2T. Block is moving upwards. That means force and displacement are in same directions. So work done will be positive. We will write 2T into A2. Summation of these two will be equal to 0. Take T as common, so it will be T into minus A1 plus 2A2 is equal to 0. That means either T is equal to 0 or minus A1 plus 2A2 is equal to 0. Since T is not equal to 0, so minus A1 plus 2A2 is equal to 0 or A1 is equal to 2A2. So we have got our constraint relation. Now we can use equation 1, 3 and 4 to figure out A1 and A2. Now we know how to figure out string constraint relation. Let us talk about wedge constraint. Suppose this wedge is moving horizontally with velocity v. A vertical rod is moving vertically downwards with velocity u. Its tip is touching the wedge. The condition that its tip should keep touching the wedge is components of their velocities perpendicular to this plane should be equal, and that is u cos theta is equal to v sin theta or u is equal to v tan theta, where theta is angle of inclination of this plane. In next video, we will talk about friction. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.